Hello everyone, greetings from ESE Engineering Academy and ESE Online. Myself Rajendra. So today we are going to discuss the important concepts and questions regarding the subject Power Electronics for GATE and ESE 2024. Right? So my dear friends, 2 days back already we discussed the points to be focused, right, as per the different chapters. Okay, so now here we are going to discuss some important questions, and while solving those questions we are going to discuss the particular concept. All right, yes. So let us start here with this simple question: which of the following does not cause permanent damage of an SCR? And they have given the options as high current, high rate of rise of current, high temperature rise, and high rate of rise of voltage. So these are the 4 options. Yes, can anyone? You can post your answers in a chat box. You can post your answers in a chat box. Yes, this is a simple question. This type of question you can expect in engineering services examination as well as in a GATE examination. Okay? Yes. This is a theory question. Yes, can anyone? Yes, Bharat has answered it as a high rate of rise of voltage. Yeah. Good, good. Yeah, let us discuss. So here, which of the following does not cause, he is asking, does not cause permanent damage of an SCR. So if you check, in SCR, we are having turn on methods of the SCR, right? In that we are having the various methods, okay? So here, or in a protection of SCR also, we are having the different protections. So let us discuss with this high rate of rise of current. High di by dt, rate of rise of current means high di by dt. So high di by dt, if you recall the protection of SCR, we are protecting the SCR against the 4 things. One is a over voltage, over current, high du by dt and high di by dt, right? So out of those 4, one of the protection is a protection against high di by dt. So my question is, why we are protecting the SCR against high di by dt? The reason is, due to the high di by dt, your SCR may get damaged due to creation of local hotspot. So due to the high di by dt, there is a possibility of creation of local hotspots. And this local hotspot creation is having a relation with your gate triggering, right? And because of that local hotspot, your device may get damaged permanently. Okay, so here high rate of rise of current, this cannot be the answer. Okay, because due to the high di by dt, there is a possibility of creation of local hotspot, and due to the local hotspot, your device may get damaged permanently, right? Next one is a high current. High current. So as I said, in the protection of SCR, we are having the over current protection. So high current means what? It is like your over current. Every semiconductor device or every power semiconductor device is having some current rating. Current rating means what? It indicates the maximum current carrying capacity of your device. If a very high current flows through the device, what will happen? Due to the high current, your device will cause a high power losses. Due to high power loss, high heat is getting generated, and due to the high heat, your device temperature will exceed the allowable temperature limit and your device may get damaged permanently. Okay, so therefore due to the high current also my device may get damaged permanently. So option A is also, it cannot be the answer. Next we are having the high temperature rise. So just now as I said, every semiconductor device is having a temperature withstanding capacity, right? If my device temperature exceeds the allowable temperature limit, then my device may get damaged permanently. And last option is the high rate of rise of voltage, that is a high du by dt. Due to the high du by dt, what happens? So now due to the high du by dt, there is a possibility of your device may get false triggered, right? So due to high du by dt, your SCR may false trigger. I am using the word here, false trigger. False trigger. If you recall the turn on methods of the SCR, we are having the various turn on methods. In that one of the method is a dV by dt triggering, right? dV by dt triggering. So here the false triggering means what? At this particular instant I am not interested in turning on a SCR, but due to sudden high dU by dt, my SCR can turn on, my SCR may turn on, and that is known as a false triggering. I am not interested in turning on a SCR, but then also my SCR is turning on because of high dU by dt, that is nothing but a false triggering. So always keep in mind, high dU by dt will not cause a permanent damage, it only cause a false triggering of your SCR. Whereas all other things, right, all remaining three options, those will cause the permanent damage to your SCR, right? So my dear friends, here the correct answer is option D. Option D is the correct answer, right? Yes. Next, yeah, this is the question, let us discuss. One of the simple question. Yeah. A steady DC current of 100 ampere. Steady DC current means a constant current of 100 ampere is flowing through a power module S, D. Through a power module S, D as shown in the figure. So this is your power module they have shown, right? Means you can consider it is like your composite switch also. So what they have given here? Yes, this is your IGBT and this is your diode, right? See these two devices, this will form a composite switch. This will form a composite switch. Next, the VI characteristics of the IGBT and the diode are shown in figure B and C. So this is a figure B, this is a figure C. They have shown the VI characteristic of IGBT, VI characteristic of a diode, right? Now, respectively, the conduction power loss in the power module in watts is. So they are asking conduction power loss means on state power loss, or you can say that average on state power loss in this module, in this composite switch they are asking. Okay, and now if you check here, if this is a composite switch they have given and the direction of the current they have already mentioned. Yes, direction of current is now upward direction, na? Direction of current is in a upward direction. So now tell me, if my current is in a upward direction, then out of this S and D, through which device my this current of 100 ampere will flow? Come on. If my current is in upward direction, out of this S and D, through which device this 100 ampere current will flow? Yes, can anyone? Whether it will flow through your IGBT or whether it will flow through your diode. Come on. Yes, good. Yes. So that 100 ampere current will flow through which device? That 100 ampere current will flow through diode, na? Right? For your diode, this 100 ampere current is nothing but a forward current. So this 100 ampere current will flow through only diode. This is your IGBT. IGBT is a unidirectional device, right? It will not carry the reverse current. IGBT will allow current only in a downward direction, right? That is from, this is for IGBT, this terminal is like gate, this is like emitter, and this is like your collector. So your for IGBT the current will be collector current, and that will be only in a downward direction. But here they have mentioned the current is in a upward direction. So this current will flow only through a diode. Means if current is flowing through the diode, then tell me the power loss is taking place only in a diode, na? Yes or no? Right? No power, no current is flowing through IGBT, so no power loss in IGBT. So power loss is taking place only in a diode, only in a diode. And we know when diode is in a on state, how it is modeled? Yes, when diode is in a on state. Recall the piecewise modeling of devices, right? We are having the three models, na? We discussed. One is for MOSFET, one is for BJT, and third one is for all other switches. So for diode, when diode is in a on state, diode is represented equivalent to the third modeling, that is VT in series with R-on. VT in series with R-on, right? This is the diode when it is in a on state is represented. And what is the power loss in this case? Yes, power loss in this third modeling is equal to VT into I average plus I RMS square into R-on. I RMS square into R-on, right? So it is equal to, now for finding the VT and R-on, here they have given the VI characteristic of a diode. From this VI characteristic, we can find the VT and R-on. So if you check this VI characteristic, now from this, can I say that for my diode, the minimum voltage required to turn on the diode is nothing but this is 0.7. So VT is nothing but how much? 0.7. And R-on is nothing but on state resistance. R-on is nothing but slope of this line, right? Or dV by di they have already given, okay, right? So it is 0.01 into 0.01 ohm. So this is nothing but your R-on, and this is nothing but your VT, right? VT and R-on, right? So for the second, this figure C we need to refer, because no current is flowing through IGBT, so you need not to refer this characteristic, alright? So only this we need to refer. So here VT is 0.7, and what is the I average? If 100 ampere constant current is flowing, means average value and RMS value is same 100, and I RMS is also 100 square into R-on is 0.01, right? So we can easily simplify this, right? And from that we can get the P average, right? We can get the P average. Yes, check the P average. Yes, it is 170, right? Is this clear, right? So you need to think here the direction of the current and which device will be in a conduction mode. That's it, okay? And from this characteristic we can find VT and R-on. All right. Next, let us discuss this question. A double pulse measurement for an inductively loaded circuit controlled by the IGBT switch is carried out to evaluate the reverse recovery characteristic of a diode D, represented approximately as a piecewise linear plot of current versus time as a diode turn off, right? That is diode dynamic characteristic of diode during turn off. He is saying LPAR, that is a parasitic inductance due to wiring of the circuit and is in series with a diode. the point on the plot indicate your choice by entering 1, 2, 3 or 4 at which IGBT experiences the highest current stress, right? So here they have given this diagram, and here it is a current plot, or you can say diode current plot, okay? And now they are asking at which point, that is 1, 2, 3, 4, okay? At which point, yes, IGBT experiences the highest current stress. Highest current stress means highest di by dt. The di by dt and dv by dt, these are the stresses on your semiconductor devices, okay? So highest current stress means highest di by dt we need to find. So out of these 4, 1, 2, 3, 4 points, where the di by dt will be highest, that he is asking. Now this is your diode current, all right? Here if you check, here it is my diode, here it is the load is RL, IGBT, and here it is source voltage he has given. Now tell me, if my diode current is positive, the meaning is my current flowing through the diode will be in which direction? Upward direction. Yes or no? If diode current is positive, means current flowing through the diode will be in a upward direction. And when current is negative, then the current flowing through the diode will be in a downward direction, Now why this current goes into the negative? Recall the dynamic characteristic of your diode during turn off. So we are having the reverse recovery charge concept, right? So here current positive means current flowing through diode is upward. Current negative means current flowing through diode is in a downward direction. So here first thing is first thing is, if you check before this time, let me write as t equal to 0. Before t equal to 0, my diode current is a constant current, right? Before t equal to 0, my diode current is a constant current. If diode current is constant, the meaning is in this loop your constant current is flowing. Means indirectly here you will be having the load current is a constant current, right? So here before t equal to 0, your current will be flowing only in this loop, and that current flow the diode is nothing but this current. At that time your IGBT will be in a off state. Right? Now after this point what happens? My diode current is decreasing. Diode current is positive from 1 to 2. My diode current is a positive, but it is a decreasing. Diode current is a positive, but it is a decreasing. So if I want to draw the waveform for the current flowing through the IGBT, let me write this current as ISW. ISW means current flowing through the IGBT. So if we want to draw the current flowing through the IGBT, how it will be? Yes. Now before t equal to 0, yes, this current is flowing, means it is like your load inductor is releasing energy through diode. That's it. Okay, my diode is in a on state. Like your freewheeling diode concept. Okay. Next, at that time your IGBT will be in a off state. This total current was flowing only through the diode. So at that time my IGBT current will be 0. Now here from point 1 to 2, my diode current is positive. Diode current is positive means current flowing through diode is in upward direction only. But my diode current is now decreasing. That is, diode current is now less than I0. Here my load demands the constant current, right? Load demands the constant current. Now tell me, if current in this branch is less than I0, and if I want current here is to be constant current I0, so can I say that the current flowing through the switch is nothing but I0 minus your diode current. So how will be my ISW waveform? Yes, ISW waveform will be like this. This current is here. Please understand this. Here current is a I0. Here current is a I0. Please listen. During 1 to 2, my diode current is decreasing. But I want switch current plus diode current, this addition to be maintained equal to load current capital I0. So here if my diode current is decreasing, in order to maintain the load current to be constant, my ISW, that is a current flowing through the IGBT, should be increasing. If you add these two values, if you add these two waveforms, you will be getting the constant current I0. Constant current I0. This will continue till point 2. Now during point 2 to 3, what is happening? My diode current is now negative and increasing. So diode current is negative and increasing means, can I say that my diode current is now in which direction? Upward or downward? If diode current is negative means diode current is in a downward direction, right? So here if you check, this branch current we require constant I0. Here current is now in a downward direction. So now my switch current is nothing but addition of these two currents, na? Switch current is nothing but addition of load current and your diode current, right? Because 2 to 3 my diode current is negative. So therefore, if I draw the plot for switch current, it will be again like this. It will be greater than now I0. It will be greater than I0 till point 2 to 3, right? Till point 2 to 3. You can check. This is now negative current. This is positive current. If you add these two, you will be getting the load current constant I0. Now during 3 to 4, what is happening? My diode current is negative, but it is now decreasing. If diode current is negative means downward direction. This is downward direction, this is constant current. So my switch current will be again addition of these two currents, addition of these two currents. But my diode current is now decreasing. So therefore addition of these two currents will be now decreasing, and it will reach to which value? At point 4. At point 4 it will reach to again I0. Please understand this. This is a plot for current flowing through the IGBT, right? Now from this he is asking, out of these 1, 2, 3, 4, this 1 is nothing but here, 2 is nothing but here, 3 is nothing but here, and 4 is nothing but here. So out of these 1, 2, 3, 4, tell me at which point my IGBT will experience highest di by dt. So your IGBT will experience highest di by dt at this point, and this point is nothing but point 3. This point is nothing but point 3. Because before point 3 your current flowing through the IGBT had a positive slope. After point 3 the current flowing through the IGBT is having a negative slope. So therefore the di by dt at this particular point is the highest one. So therefore your IGBT will experience highest di by dt at point 3. At point 3. So please understand this. This question they asked in one of the examination, gate examination. Okay, right? So here you need to think how will be my ISW waveform, right? That is IGBT current waveform. IGBT current waveform is nothing but simply you need to think about diode current waveform and load current. Load current waveform is a constant, right? And if diode current is positive, means diode current is in an upward direction. That is from anode to cathode. And when diode current is negative, means current through the diode is in a reverse direction, right? Reverse direction. You might be thinking, sir, how the diode can allow the reverse current? Here, this characteristic they have shown as like a dynamic characteristic during a turn off, and we know during dynamic characteristic during turn off, my diode current goes into the negative values because of the stored charge carriers. Yes or no? Because of stored charge carriers. Is this clear? Right? So this question is important question. In one of the examination they asked the, right? Yes. Next, let's discuss one more question. A thyristor T in the figure below is initially off and is triggered with a single pulse width of 10 microseconds. So pulse width is given, right? Triggered with a single pulse width means indirectly he has given the width of your gate signal, width of the gate signal. It is given that L is equal to 100 by pi microhenry and C is equal to 100 by pi microfarad. Assuming latching and holding currents of the thyristors are both 0 and the initial charge on capacitor is a 0, thyristor conducts for, right? So he is asking for how much time this thyristor will be in a conduction mode, right? So before t equal to 0, your thyristor will be in a off state. And suppose at t equal to 0, you are applying the gate signal and now your thyristor starts conduction. Okay, thyristor starts conduction. And now he is asking for how much time your thyristor will be in a conduction mode. Thyristor will be in a conduction mode. So my dear friend, here this is a circuitry. DC voltage, switch, inductor and capacitor. Inductor and capacitor. This type of circuit is nothing but your class A commutation circuit. Class A commutation circuit. So for this circuit here, suppose before t equal to 0, before t equal to 0, my thyristor is in a off state. Thyristor is in a off state, right? At t equal to 0, at t equal to 0, I am turning on the SCR by using gate signal. SCR is turned on using gate signal, So my SCR will turn on. Now tell me, at t equal to 0 when SCR turn on, what is the status of inductor? We know inductor is the element that opposes the sudden change in current. So before t equal to 0, when SCR was in a off state, my circuit current will be 0, right? Let us consider this is my circuit current I. So my circuit current will be 0, right? So here before t equal to 0, my circuit current is a 0 ampere. At t equal to 0, when I apply gate pulse to SCR, my SCR will turn on. But inductor will not allow the sudden change in current. So at t equal to 0, your inductor will act as an open circuit. And at t equal to 0, capacitor will act as a short circuit, right? Recall network transients, okay? So this will act as open circuit, this will act as short circuit. Now tell me, at t equal to 0, if inductor acts as an open circuit, what is the circuit current now? Again 0, na? So here my circuit current is again 0 ampere at t equal to 0, at t equal to 0, right? Now for t greater than 0, how will be my circuit? For t greater than 0, my circuit will be like this. DC voltage, SCR is in a on state, inductor, and here it is a capacitor. This is 15 volt, let me write it as Vs. This is thyristor L and C, and this is your circuit current I. This is your circuit current I, alright. Now, if we apply KVL to this loop, yes, this is like simple. DC voltage connected across LC branch. We are having the standard expression for current. Here I am explaining how to find the expression for current, okay? Yes. So here you will be getting it as plus 15 or plus Vs. Let me write in terms of Vs, general way. So I can write it as plus Vs minus L into di by dt minus 1 by C integration of I dt equal to 0, right? If you solve this using Laplace transform, you will get the expression for current as I is equal to Vs under root C by L into sine of omega 0 into t. Vs under root C by L sine of omega 0 into t. Alright. Now this is the expression for current, which is a sinusoidal in nature. And what is the expression for voltage across capacitor? Vc. Vc is nothing but 1 by C integration over 0 to t I into dt, right? I into dt. So here I can replace this I with this expression and I can simplify, okay? After simplification I will be getting it as Vc equal to Vs into 1 minus cos of omega 0 t, right? This is the expression for Vc. This is the expression for Vc, and this is the expression for current I. Expression for current I. So here my waveform of the current I is like this. Let me write it as t 0. So here current I waveform will be sinusoidal type thing. Current I waveform will be sinusoidal type thing. This time is like pi by omega 0, right? Sinusoidal type thing. Okay, this is a sinusoidal type thing. Okay, and this time is a pi by omega 0. Pi by omega 0. Now here he is saying that we are applying the gate signal only till 10 microsecond. Only till 10 microsecond we are applying the gate signal. Okay, so first of all we need to check at t equal to 10 microsecond. Put here t equal to 10 microsecond. Then what is the value of current I, right? What is the value of current I? But if you check at 10 microsecond, definitely my value of current I will be non-zero na. Value of current I will be 10 microsecond means will be non-zero, right? And this current value is non-zero means this current value is definitely greater than that of the latching current. He is saying that latching current is how much? Zero na. Latching current is zero. So therefore here my thyristor after 10 microsecond, even though if you remove the gate signal, then also my thyristor will continue into the conduction mode, right? And how will be the waveform for the voltage across capacitor? Vc. Voltage across capacitor is this expression na, Vs into 1 minus cos of omega 0 into t. At t equal to pi by omega 0, put here t equal to pi by omega 0. You will get 1 minus cos pi. Cos pi is a minus 1. 1 minus of minus 1, 2. So my voltage across capacitor is 2 Vs, right? So at this point, my capacitor voltage will become 2 Vs. Capacitor voltage will become, it is like a 2 Vs. Here voltage is 2 Vs. So always keep in mind, if you are having a DC voltage and it is connected across LC branch, your capacitor always charges to the voltage which is greater than your supply voltage, greater than that of the supply voltage. Why my capacitor is charging to the voltage greater than the supply voltage? The reason is till this point that is pi by 2 omega 0. Till this point my load current is increasing, circuit current is increasing. Circuit current is increasing means my load inductor is go on charging, or you can say that my circuit inductor go on charging or it go on storing the energy. And after this point my inductor is releasing energy. So when inductor releases energy here, then in this circuit your inductor is also giving the energy to your capacitor, and supply voltage is also giving the energy to the capacitor. So that's why my capacitor voltage greater than the supply voltage, right? It will become greater than the supply voltage. So now in this circuit, if you check at t equal to pi by omega 0, my capacitor voltage will become 2 Vs. Here voltage is 2 Vs, right? This side voltage is 15 volt, that is Vs, right? And my circuit current will reach to which value? Pi by omega 0. And as per this expression, after pi by omega 0, my current will try to increase in which direction? Negative values na. This current waveform is a sinusoidal. So after this pi by omega 0, my current will try to enter into the negative values. Negative value means this current will try to reverse here. This current will try to circulate in an anti-clockwise direction. But tell me whether my thyristor will allow the reverse current? No. So therefore my thyristor will stop conduction at this particular point pi by omega 0, right? So therefore here if he is asking that conduction time of thyristor, right, then it is only pi by omega 0. Conduction time of a thyristor T is equal to pi by omega 0, where omega 0 in this expression, omega 0 is equal to 1 by root LC. So therefore, you can write conduction time of a thyristor T is equal to pi into root LC. So you can put the values pi into root LC, okay, right? So from this you will get the conduction time of the SCR, right? Conduction time of the SCR. Is this clear, right? Yes. Next, so please understand here, this is a class A commutation, simple class A commutation, this is known as. Next, a half controlled single phase bridge rectifier is supplying an RL load. It is operated at a firing angle alpha and the load current is a continuous. Load current is continuous means conduction is a continuous. The fraction of cycle that the freewheeling diode conduct is, yes, simple question. He is asking what is the fraction of cycle the freewheeling diode conduct. Yes, can anyone? What is the fraction of cycle the freewheeling diode conduct? Yes, what is the fraction of cycle freewheeling diode conduct? This is a simple question, right? You can post your answers in the chat box. Yeah, he has given half controlled means what? Semi-converter, right? In a semi-converter, if a freewheeling diode is connected, then during which interval your freewheeling diode will conduct? Yes, if I want to draw the freewheeling diode current waveform, how it will be? 0 to alpha, pi to pi plus alpha, and here 2 pi. Alpha, pi, pi plus alpha, and 2 pi. So my freewheeling diode will conduct during which interval? 0 to alpha and pi to pi plus alpha. So corresponding to 2 pi radian, my freewheeling diode will conduct for how much angle? Alpha plus alpha, that is 2 alpha. So fraction means 2 alpha by 2 pi. So it is equal to alpha by pi. So it is equal to alpha by pi, right? So option D is the correct option. Is this clear, right? So your freewheeling diode will conduct 2 times. Freewheeling diode will conduct 2 times, right? Corresponding to 1 input cycle of the supply. So that's why it is alpha by pi. Alpha by pi. So option D is the correct option. Next. Yeah. A 3-phase diode bridge rectifier. Diode bridge means we are having the 6 diodes connected in a bridge configuration. 3-phase rectifier is feeding a constant DC current of 100 ampere, means load current is constant, that is the load is highly inductive. Next, if a 3-phase 415 volt 50 hertz AC source is supplying to this bridge rectifier, then the RMS value of a current in each diode in ampere is, yes, what is the RMS value of current flowing through diode? How will be your diode current waveform? Let me write it as ID1. How will be the diode D1 current waveform? During which interval your diode D1 conducts? This is 3-phase 6 pulse rectifier, right? So during pi by 3 omega t equal to pi by 3 till omega t equal to pi, right? Your diode D1 conduct, and during this interval which current flows through diode D1? Load current. Which current flows through diode D1? That is a load current, right? Out of 2 pi. Out of 2 pi. So from this we can write ID RMS. ID RMS is equal to this is a pulsating waveform we will be getting. So RMS is equal to amplitude square into function duration upon periodicity to the power 1 by 2, right? So it is equal to I0 by root 3. I0 by root 3. So it is like 100 by root 3, right? I0 is 100 na? So that's why it is 100 by root 3. 100 by root 3 ampere, right? Yes. So in a 3-phase full wave rectifier, each switch for continuous conduction highly inductive load, each switch, that is nothing but diode in case of uncontrolled rectifier, and thyristor, that is SCR in case of controlled rectifier, conducts for how much angle? 120 degree, right? So pi by 3 till pi, okay? So it is 100 by root 3, 100 by root 3. Next, yes, in the circuit shown, the diodes are ideal, the inductance is small, means this side inductor is like your source inductor, this is like your source inductance, and load current is a non-zero. Load current is represented with a constant current source, means your load is a highly inductive. Which one of the following statement is true? This is diode D1, this is diode D2. Highly inductive load, source inductance is present, okay? So which of the following statements is true? And they have given the statements. D1 conducts for greater than 180 degree. D2 conducts for greater than 180 degree. Second, D2 conducts for more than 180 degree and D1 conducts for 180 degree. And similarly, C and D statement he has given, right? Means he has given the statements regarding the conduction angles of your diodes. Yes, can anyone? Come on. You can post your answers in a chat box. So here source inductance is present, load is highly inductive, and a freewheeling diode is also connected, right? Freewheeling diode is also connected, and he has given these statements. Yes. So D1 and D2 conducts for how much angle? That is greater than 180, less than 180, or equal to 180. Like this he has given the statements, right? So if the source inductance is present, how will be my diode D1 current waveform? Yes, diode D1 current waveform. Or first let me draw the diode D1 and D2 current waveform when source inductance is not present. When source inductance is not present. So tell me, if source inductance is not present, that is without LS. Without LS, my diode D1 current waveform and diode D2 current waveform, it will be like this. Without LS I am saying. 0 to pi diode D1 conduct, and during pi to 2 pi what happens? Inductor will release energy through diode D2, that is freewheeling diode. So my diode D2 current waveform without LS will be like this. Same I0 here, right? If a source inductance is not present, then the current flowing through diode D1 waveform is like this. Current flowing through diode D2 waveform is like this. It is like a simple single phase half wave uncontrolled rectifier with a highly inductive load and freewheeling diode. During 0 to pi diode D1 conduct if LS is not present. And after pi supply voltage is negative, that is polarity plus here minus here, this will become reverse bias, inductor starts releasing energy through diode D2. So without LS my waveform of ID1 and ID2 is like this. Now tell me, if LS is present, if a source inductor is present, whether this source inductor will allow the current flowing through this diode D1, whether your source inductor will allow the current flowing through diode D1 to change suddenly from 0 to non-zero value at omega t 0 and to change suddenly from I0 to the 0 value at omega t equal to pi. No, because this is an inductor. What is the basic tendency of inductor? Inductor opposes the sudden change in current, right? So therefore if LS is present, this LS will not allow this ID1 to rise suddenly and this ID1 to fall suddenly here. So therefore what will happen, my diode D1 current waveform, when LS is present, it will be like this. So I am drawing here with LS. So with LS my diode D1 current waveform will be like this, ID1 omega t 0 slowly increasing and here it is slowly decreasing. This we represent it as a mu na, and this is like a pi plus mu. If source inductance is present at omega t 0, my LS will not allow this current to rise suddenly here and to drop suddenly here. So therefore my current will go on increasing slowly till pi it will be I0, and after pi it will go on decreasing slowly. If this is my ID1 waveform, then how will be my ID2 waveform, right? This is again definitely out of 2 pi, right? This is again definitely out of 2 pi. Let me write here. Yes, out of 2 pi. Now how will be my diode D2 current waveform, ID2 waveform? Yes, please understand now. So here during 0 to mu, my diode D1 current is increasing, but it is less than I0. Means current in this branch is now during 0 to mu is less than I0. But here I require which current? We require here constant current I0. And if this current is less than I0 and here required current is I0, so therefore the remaining current will flow through which device? Diode D2. Right? So my diode D2 current waveform will be like I0 minus ID1 waveform. So therefore my diode D2 current waveform will be like this. From 0 to mu, it is like this. It is decreasing from this I0 towards this 0. At mu, it will become 0. If you add these two curves, your current will become constant current I0. At omega t mu, my diode D1 current will become I0. Then your diode D2 current will become 0. Means your diode D2 will turn off. From here till this point, my diode D2 current will be 0. Right? Again from pi till pi plus mu, my ID1 is now decreasing and it is less than I0. So if this current is less than I0, but my load will not accept the current less than I0. So therefore what will happen? Whatever the difference current between these two, my load will release energy through this part. Means my diode D2 current will be like this here increasing. Right? And after that it will be constant I0. And after 2 pi, 0, 2 pi and 0 both are same na? In continuous cycle operation 2 pi is nothing but again 0. 2 pi is nothing but again 0. Right? So therefore what will happen? My current, whatever waveform here na ID2, the same will be getting here. This is like 2 pi plus mu. Right? 2 pi plus mu. Now tell me the conduction angle of D1 and D2. Here D1 conducts for pi plus mu. Yes or no? Pi plus mu. From 0 till pi plus mu, D1 conduct. And D2 conduct from, yes, if you check 0 to 2 pi, in 0 to 2 pi, my D2 conducts from pi to 2 pi and again 0 to mu. So total conduction angle of diode D2 is mu plus this 180, that is pi plus mu again. Okay, so I am writing here D1 and D2 conduct for, yes, pi plus mu angle, that is greater than 180 na, greater than 180, right? So D1 conduct for greater than 180 and D2 conduct for greater than 180, right? D1, D2 both conduct for greater than 180. Is this clear? Right, let us discuss one more question. Yeah, simple question. A single phase full bridge diode rectifier fed from 230 volt 50 hertz sinusoidal source supplies a series combination of finite resistance R and a very large inductance L. Large inductance means your load current is now constant again. The two most dominant frequency components in the source current. Most dominant frequency components in a source current he is asking. So here single phase full bridge diode rectifier and load is highly inductive. How will be my source current waveform? Yes, can anyone? How will be my source current waveform? What is the nature of source current waveform? Yes, what is the nature of source current waveform? You can post your answers in a chat box. Single phase diode bridge rectifier and highly inductive load na, source current waveform is a, yes, square function, quasi square function, 6 stepped function. Come on. Yes, it is a square function na. How is your source current? This is my source current waveform. Right? Source current waveform, it is a square function. And what is the expression for Fourier series expression of this source current? IS equal to summation over n equal to 1, 3, 5, 7 up to infinity. It is 4 into I0 upon n pi into sine of n omega t, right? 4I0 upon n pi into sine of n omega t. So which harmonics are present here? Only odd harmonics are present. But be careful. Here he is asking the most dominant frequency components. He has not used the word harmonic. Please be careful. So most dominant frequency component means the frequency corresponding to n equal to 1 and frequency corresponding to n equal to 3. That should be your answer. So n equal to 1 means fundamental component. N equal to 3 means third harmonic component. So what is the frequency of fundamental? 50 hertz. And frequency of third harmonic? 150 hertz. Na? It is 3 times the supply frequency. What is the supply frequency? Supply frequency is a 50 hertz. Na? Right? So here most dominant frequency components should be 50 hertz and 150, that is fundamental and third harmonic. If the question is like most dominant harmonic frequency components, I am saying most dominant harmonic frequency components, then your answer should be third harmonic and fifth harmonic frequency. Because fundamental is not a harmonic, fundamental is a component. If he use the word like most dominant harmonic frequency component, if the word here harmonic is present, then you need to consider only top 2 harmonic components, that is third and fifth. Okay, but here in this case he has not used the word harmonic, so therefore most dominant frequency component you need to consider fundamental as the first one, and next will be your third harmonic. That's why it is a 50 and 150 hertz. So here 50 and 150 means option A is the correct option, right? Option A is the correct option. Is this clear? Right? So this question, yes, here he has not used the word harmonic, so that's why you need to answer it as 50 and 150 hertz, right? Let us discuss one more question. Yes, yeah, it is a simple question. I am expecting answer from you guys. This is very simple question. A half wave thyristor converter supplies a purely inductive load as shown below, right, as shown in figure. If triggering angle of the thyristor is 120, that is alpha is a 120 degree, the extinction angle will be, that is beta. He is asking the beta. Yes, alpha now for this circuit purely inductive load, alpha is a 120 degree, then what is the extinction angle beta he is asking. Extinction angle beta, load is a purely inductive. Yes, what is the expression for beta? During classroom sessions, right, offline as well as online sessions, we already analyzed this circuit. Yes. What is the beta in here? Beta equal to 2 pi minus alpha, na? Right? Beta equal to 2 pi minus alpha. In this circuit, the angle corresponding to energy stored and angle corresponding to energy released, both will be equal, right? So beta will be 2 pi minus alpha. So 2 pi means 360 minus alpha is 120. So it is 360 minus 120, that is nothing but 240 degree. So my beta will be 240 degree, right? Beta will be 240 degree, right? Yes. So my dear friends, these are the few questions we discussed here, but this session is only for 1 hour, right? But in the previous session, I have already listed the important points or points to be focused. Please try to prepare those points and please try to solve the previous year question papers. Definitely the previous year question papers will help you during your final examination. Because of the previous year question paper, you will get idea on which topic, which type of the questions they can ask. Okay. So therefore, please refer the previous year question papers, and also if possible, try to subscribe for your test series also, right? Because test series will definitely help you. Okay. So please go through the latest session, whatever we discussed, preparation strategy of power electronics, and after that you can refer this, you can go through this video. All right. Yes. Thank you and all the best for your examinations. Yeah.